Hello everyone, this is Gokul from Simplilearn and I welcome you all to this interesting session on Python Bokeh. Bokeh is one of the Python library used to create data visualizations like graph plots, bar charts, interactive dashboards and other applications. So in this video, we'll help you understand how to build all these creative and beautiful visualizations using Python Bokeh. But before we begin, if you're new to the channel and want to learn about all the latest technologies, make sure you subscribe to our channel SimpliCode. Also, hit that bell icon to never miss an update from us. So without any further delay, let's get started.
Before we dive into this video, let's get a basic overview of what you can expect to learn from this video. What's in it for you? So first, we will explain what exactly the meaning of bokeh is. Then, we will take a look at scatter charts and see how we can implement them in bokeh. Next, we'll understand what line charts are, the scenarios in which they are used, and how they can be coded in Python Bokeh. Then we'll move on to pie charts and understand how data distribution can be represented using them. Next, we will take a look at histograms. Then we'll move on to bar plot and understand the difference between histograms and bar plots. We'll then take a look at area plot and how to understand them. And then we will move on to the layout function in Bokeh, which is used to make interactive web pages. And finally, we will use a data set to understand how we can make interactive charts in Bokeh by using everything that we've already learned in this video. So the first question that probably comes to your mind is, what exactly is Bokeh? Bokeh is a Python library which is used to make highly interactive graphs and visualizations. This is done in Bokeh using HTML and JavaScript. This makes Bokeh a powerful tool for creating projects, custom charts, and web design-based applications. Now, Bokeh is a Python library for creating interactive visualizations for modern web browsers. It helps you build beautiful graphics ranging from simple plots to complex dashboards with streaming datasets. With Bokeh, you can create JavaScript-powered visualizations without writing any JavaScript yourself. This makes it a very powerful tool for data visualization. Next, let's take a look at scatter charts and how you can plot them in Bokeh. Now, scatter plots are a plot of each individual data point in the data. Two variables are plotted against one another, and each data point on the x-axis has a corresponding individually plotted value on the y-axis. As a result, the plot looks like a bunch of scattered points. These are some examples of scatter charts. Here, each point on the chart corresponds to a value on the x-axis and its respective value on the y-axis. Using scatter plots, we can see how two different variables correspond to each other. Now, let's see how we can plot scatter charts using Bokeh. So the first thing that we're going to be doing is importing all of the necessary modules for our Python project. The first module that we're going to need is the pandas module, which is used to work on data frames. Next, we will also be importing the pandas Bokeh module, which is used to implement Bokeh on pandas data frames. Next, we will import bokeh.io, which we will use to show the various graphs that we are plotting. We will also import bokeh.plotting, which will help us in plotting all of the various graphs that we're going to be looking at. We'll also import glob, a module which will help us merge our files and get them in the required format. So the first line of code that we're going to be writing is pandas_bokeh.output_notebook. This is basically just a line of code which will help you see your output in the same notebook itself. Now let's see how we can plot scatter plots in Bokeh. We already have imported the figure function from bokeh.plotting. The figure function contains most of the plots that we want to plot, such as line plots, scatter plots, bar charts, etc. So this is what we're going to be using. The first thing that you're going to need to do is create a figure. So how do we do that? Let's create a random variable p, and this we're going to be initializing to the figure function. Now within this figure function, we're just going to add a couple of parameters for our figure itself. So let's say we want the plot width to be equal to 400 and the plot height to be equal to 402. We're going to be plotting a scatter plot in the form of a square here. Next, we know that a scatter plot is nothing but various circles which are plotted on top of our graph. So that's what we're going to do. We're going to be plotting circles at certain coordinates which are going to be given by our lists. So the first coordinate is going to be the x-axis, and the next list that you're passing in is going to represent the y-axis coordinates. So over here, let's just plot this as 1, 2, 3, 4, and 5. And over here, let's start with 4, 7. These are all just random points. This is just to show you how exactly you can plot a graph in Bokeh. And now let's just say that we want the size of the circles to be equal to 10 and the color of every circle to be navy. We're also going to give a random parameter called alpha and equate that to 0.5. This will just act as a placeholder. Now over here, you've initialized your figure function and given it certain parameters. And using this figure function, you're calling the circle attribute of it, passing in other parameters such as the x-axis coordinates and the y-axis coordinates, the size of the circle, the color of each circle, and a random parameter called alpha. So now we've imported all of our modules. And this is how you plot a scatter chart in Bokeh. The same thing can be done when you look at the line plot. All you have to do is initialize your figure function and call the line attribute of it, pass in your x-axis coordinates and your y-axis coordinates, maybe pass in a couple of other parameters that are required, such as the width that you want the line to be and the color that you want the line to be, and finally all you have to do is show the plot. This is a basic overview of how you can use Bokeh to plot graphs. And here we have a line plot. So the main difference between the scatter plot here and the line plot here is that the line plot has various different points which are connected to each other with the help of a line. So again, what exactly are line charts? A line chart is a chart that represents data as a series of points which are connected to each other with the help of a line. It is used to see trends in our data and track the way data changes over a period of time. So this is the same chart that we just plotted using Bokeh right now. So as you can see, so the parameters that you know were passed in were 1, 2, 3, 4, and 5 on the x-axis, and 3, 1, 2, 6, and 5 on the y-axis. So how exactly the line chart is plotted is that you plot each of these points and then you connect them or join them using a line. Next, let's take a look at pie charts and how they can be implemented in Bokeh. But first, what exactly is a pie chart? A pie chart is a circular chart which is divided into slices to represent how much of the data belongs to a certain category. It is a quick and easy way to see the categories in our data and the percentage of the data set that they represent. On the other hand, you have another type of chart called a donut chart. Donut charts are like pie charts with a hole in the center. And in this hole, you can use it to represent extra data, or you can draw a pie chart within that hole itself. So this is an example of a pie chart. Using this, you can easily get to know the various categories that our data is divided into and the percentage that each of these categories contribute towards our data. Like over here, we have a pie chart which represents crewmates and imposters in a game called Among Us. So using this, we can just say that around 75% of our data is crewmates and 25% of it is imposters. On the other hand, you have a donut chart which is almost exactly the same as the pie chart, except the middle portion is missing values. And in this middle portion, you can do other things such as plot a pie chart or represent other data within it. So now let's see how we can plot our pie plots using Python Bokeh. But first, we need to import the data that we're going to be using to plot all of this. So the data that we're going to be looking at is the Among Us data. Among Us, as you might know, is a game that caused quite a frenzy in the past 2 years. So the data that we're going to be working at is the Among Us data set that you can find on Kaggle. Among Us was the new craze for people playing mobile games that suddenly exploded in popularity and became a hit video game during the pandemic. Now, Among Us is basically a multiplayer game where 4 to 10 players are dropped in an alien spaceship. Each player has their own role of imposter or crewmate. The task of the crewmate is to run around the spaceship to complete various tasks which are assigned to them and also to not get killed by an imposter. Players can be voted off the ship, so each game becomes one of survival. So let's load this data set and create more features. So now we've imported our data set. As you can see, our data set has over 2000 rows and 14 columns. The first column that I want to show you is the user ID column. The user ID column tells us which user the game data was collected from. Now there are 14 columns. The game completed data tells us the date and time of game completion. The team tells us if the player is an imposter or a crewmate. The outcome tells us if the game was won or lost. So over here, this is each game that a certain user has played. The user ID is used to represent the user who has played the game, and as you can see, we've collected data from 29 different people. And the number of games that these 29 people totally have played is over 2000. The outcome tells us whether the user has won or lost in this game. The task completed tells us how many tasks was completed by this user in this game. All tasks completed tells us whether the user was able to finish their tasks. Murdered tells us if the user was murdered. And imposter kills tells us the number of kills by the imposter. So if the user was not an imposter, we do not have data on how many kills was committed by the imposter during that particular game. That's why this column has a lot of missing values. Game length tells us the total duration of the game, and ejected tells us if the player was ejected or thrown off of the spaceship by their fellow players. Sabotage is fixed is basically the imposter within the game can create sabotages, and it's the crewmate's duty to fix them. So this tells us the number of sabotages which was fixed by this particular crewmate. Time to complete all tasks tells us the duration taken by the crewmates to complete all the tasks, and the rank change tells us the change in rank after wins or losses of the game. The region or the game code tells us the server and the game code. Now first, let's just see how exactly the data is distributed. So this tells us how many counts each column has. So as you can see here, most of them have the same number of counts except rank change, which has a couple of missing values. Unique tells us how many unique values exist in each column. So obviously team, there will be 2 because there are only 2 possible outcomes. You can either be a crewmate or you can either be an imposter. Outcome also has only 2 unique values because you either win a game or you lose a game. Task completed has 12 different values, and this is because the number of tasks which have been completed probably range from 1 to 12. All tasks completed has 3 values, which is yes, no, and missing data. And the same goes for murdered. You have yes, no, or missing data. Imposter kills tells us how many kills the imposter has made. So in this case, the most kills that the person has made is probably 9. Game length, there are 988 different values, and ejected, again there are only two values because you can either be ejected or you can either stay in the game. Now the top value tells us the most frequently occurring value, and the frequency tells us the frequencies of all of the top values. Now let's create a feature called minute and extract data from game length. So we're going to be splitting the game length column, which is this column, and we're going to be converting it into minutes. And then we're going to be using that data and creating a separate feature column called minutes out of it. So let's do this. So these are the first top two values of our new minutes column. The 0th value is 7 because the first game length that you see here was of 7 minutes. So all that we're doing is that we're going to be splitting this value, which is 7 minutes 4 seconds, and we're going to be keeping only the first value, which is that of the minutes. The second minutes value is 16 minutes, and that corresponds to the second value in our minutes feature variable. Now let's take a look at the murdered column. The murdered column has yes no values and missing data set and missing values. So let's change those. We're going to be replacing no values with not murdered, yes values with murdered, and the simple dash with missing. And we're going to be doing this in place, which basically means that this is going to make a change to our main data frame. So this is done. Let's take a look at our data frame now. This is what our data frame looks like. We have a game's length column, we have a minutes column, and we also have made changes to our murdered column, which is represented here. So now we don't have any missing values or dashes in our murdered column. We have all of it represented as categorical data. And this is one of the main columns that we're going to be using to plot our pie plots. So now let's see how we can plot a pie chart. The first thing that we're going to be doing is that we're going to be getting the total value counts in our team column here. So we're going to be plotting a pie chart with the help of this team column, and we're going to be getting the value counts of each unique value in the team column. So you can do this with the help of the value counts function that Pandas data frames provides us with. And now that we have the value counts of each unique value which is present in our team column, let's plot it in the form of a pie chart. We're going to be doing this with the help of the plot bokeh function. And the type of chart that we want to plot is a pie chart. Let's give it a title as ratio of imposters versus crewmates, and let's run this now. And this is what your pie plot looks like after you've plotted it. So now the same thing can be done to plot a donut plot. The first thing that we want to see is if there are more crewmates or imposters murdered or not in the game. To do this, we will add two more features, angle and color, which are going to be used in the chart. So to get angle, we're going to be importing pi from math, and we're going to be converting our angle in the form of radians. And as for the color feature, we're going to be having 3 different shades of blue. So this is basically what our murdered data frame looks like. So over here you have not murdered, the total value counts of which is 894, and the angle that this gives us is 2.522302, and this is the corresponding color. The same goes for murdered, which is 867 values, and we've converted that into an angle in radians and given it its own color. And finally we also have missing values, of which there are 466. The angle is 1.314756, and it has its own corresponding color. So this is a data frame that we're going to be using to plot our donut chart. So from bokeh.transform, we import cumulative sum, and the cumulative sum is what we're going to be using to find the start of our angle, or basically to find how much portion of our donut chart is going to be occupied by the angle. So the donut chart can be plotted using the angular wedge function from figure. So the x-axis here is 0 and the y-axis is 1. The inner radius is the radius that you are going to be giving to the inner smaller circle, and that we've given as 0.15. The outer radius is the radius of the bigger outer circle, and the direction in which our data is going to be plotted is in the anti-clockwise direction. So let's run this. And this is what our donut chart looks like. So the not murdered is this dark blue color portion of our donut chart, and when you hover over it, you can see how many values are present in the not murdered column. The same goes for murdered, and because we've plotted our data in the anti-clockwise function, this is how it's being plotted. So murdered, not murdered, and then finally you have the missing values. The way that you can interpret this graph is that you can say that most of the people were murdered during the game, but most of the data is missing. So we can't say for certain whether the majority of the people were murdered during the game or not, because the number of missing values can make a huge difference. And the number of people who were not murdered and the number of people who were murdered are very close to each other. Like their total values are very close to each other. Next, we will create a data frame of sabotages fixed and minutes and change the column name and add T in them. So this is basically what we're doing. We've created a data frame which has the number of sabotages fixed and the minutes. Now let's just take the 3 sabotages which were fixed, which is 0, 1 and 2, and create a data frame out of all of these. So each of these individual data frames just contains these individual columns. To make a simple scatter plot with only one legend, we can pass the data and use scatter to make the charts. So basically we're just plotting the scatter chart in Bokeh here. And this is what our minutes scatter chart looks like. Now we're plotting this for 1t. We're plotting the minute at which one sabotage was fixed. And another cool thing about Bokeh charts is that you can always zoom into them or zoom out of them to better see where your data is plotted. So this is a scatter chart which has only one variable, which is 1t, and the minute at which it was plotted. To make a scatter chart with more variables, we are going to need to use circle, which is a method of figure object which we've already seen before. The circle is one of the many plotting styles which are provided by Bokeh. You can also use triangles or many more. You don't have to make each point a circle. So we're going to be plotting the sabotages fixed and the minute at which they were fixed. And we're going to be plotting 3 different circles of 3 different colors. Each of them correspond to how many sabotages were fixed at what time. 0 sabotages at what time, 1 sabotage at what time, and 2 at what time. So let's run this. So as you can see here, when 0 sabotages were fixed, these were the times. When 1 was fixed, this was the time at which it was fixed. And when 2 was fixed, this is the time that it was fixed at. Now the x-axis is our minutes and the y-axis is the sabotage. When you hover over it, you can see various information about where each circle is plotted. So this has an index of 10. The data xy will tell you the exact x coordinate and the y coordinate, and the screen xy will tell you the screen pixels on which it is plotted. So now we've taken a look at pie charts. Let's move on to histograms. So what exactly is a histogram? Histograms are used to plot numerical data according to the range that they fall into. The data is plotted in the form of bins or rectangles, and the y-axis corresponds to the amount of data present in a certain range or at a certain point. So this is what a histogram looks like. This is a histogram of the distribution of minutes. So the x-axis has the range within which this data falls. Like over here, the first range is from 0 to 2.9 and the second one is from 2.9 to 5.8. Each range has a value of 2.9 and the corresponding y-axis or the height of the bins tells us how much data is present within this range. So this is how you can read histograms. Now let's see how we can plot them using Python Bokeh. Now let's see the distribution of minutes in the Among Us game. We will use hist to plot a histogram. So basically just going to be plotting the minutes of our game. We're going to be using the df min column for this, and we're going to be converting it into an integer. So this is the column that we're going to be plotting. Let's plot this. Again, we're going to be using the plot bokeh function here because it makes plotting data frames very easy. The kind of data frame that we're going to be using is the histogram or hist, and the title of our graph is going to be distribution of minutes. So let's run this. Now this is what our histogram looks like. Now this is when we've only plotted one variable, which is minutes. Yeah, so another thing that you can plot is a stacked histogram. A stacked histogram is when you plot various histograms on top of each other. So let's see how this works. For a stacked histogram, we want to see if the game length has a correlation with the amount of imposters and crewmates in our game. So to do this, we're going to be creating a small data frame which has the game length and the team columns combined. So let's do that. And this is what this looks like. So all you have to do to plot this in the form of a stacked histogram is use the hist function again. So let's see how that is done. And let's give this figure a size of, say, 750, 350 size. So let's run this again. And this is the stacked histogram that you get. We have two different columns which are plotted on top of each other versus the game length. So basically this tells us that when the game length was between 0 to 0.9 minutes, the number of imposters was way higher than the number of crewmates. And the longer the game went on, the number of imposters decreased and the number of crewmates just kept getting longer and longer. Now, obviously, you can say that the number of crewmates is decreasing as the game goes on too, but this is because the imposters would have killed off most of the crewmates. As you can see here, towards the end, there are no imposters, which means that most of the imposters were rejected and the crewmates won. So now we've taken a look at histograms. Let's move on to bar plots and understand how exactly they're different from histograms. So in histograms, you have plotted numerical data distributions as of yet. In bar plots, you plot for categorical data. It also uses bins to plot the amount of data. When the bins are stacked on top of each other, it's called a stacked bar chart. This is basically what a bar chart looks like. The difference is this does not have its own range. Each bar is used to represent a categorical data, and the height is used to tell us how much of that categorical data is present. So now let's see how we can plot a bar plot. So again, we're going to be making a small data frame of the task completed and the value counts of how many tasks have been completed. To plot a bar plot, we're going to be using plot bokeh again, and the kind of plot that we want to plot is bar. So let's run this and see what we get. So here is your bar plot. The task completed in this case is categorical data. And the counts basically tells us how many value counts fall into each category. So 0 tasks completed are 69, 1 task completed is 117, 2 tasks completed is 10, and so on. From this bar chart, you can say that the most number of tasks completed is 7 and the least tasks completed are 10. Now let's create a stacked bar chart and let's see who wins, imposters or crewmates. To create a stacked bar chart, what we're going to be doing is that we're going to be creating a different smaller data frame of team and outcome. To make sure that the bar chart is stacked, all you have to do is include a stacked attribute in your bar function and change its value to true. So let's run this and see. And here you can see that we have a stacked bar chart. So you can see that crewmates who have a lot more data have won 981 times and lost 780 times, while imposters have lost 205 times and won 216 times. So the crewmates have won significantly far more than the number of times imposters have won. Now let's take a look at stacked vertical bar charts. So far the bar charts that we've been looking at have been horizontal, which means that the data goes upwards. For a vertical bar chart, we're going to be seeing if all tasks have been completed or not. So in the data frame column, all tasks completed, we're going to be replacing the values of yes and no with tasks completed and tasks not completed. We're also going to be creating a smaller data frame of the outcome column and the task completed column. To plot a stacked vertical bar chart, you are going to be using Python bokeh.barh function, and you're going to be changing the stacked attribute to true. This is what a stacked horizontal bar chart looks like. So over here we can see that the missing values is represented by blue, task completed by orange, and task not completed by green. Here you can see the total outcome. You can see how many wins, how many tasks are completed, and how many tasks are not yet completed. And the same goes for losses. You can see how many losses have occurred, how many tasks are completed, and how many tasks were not completed. This is a very good way of representing a lot of data in a relatively smaller area. Now, the way we can interpret this graph is that we can say that finishing the task will automatically ensure that the crewmates have won. So there's a higher number of people who need to complete the task to win the game. Another very unique type of bar chart that you can have is a bidirectional bar chart. So let's plot a bidirectional bar chart in which the bars will be going both ways, to the left and to the right. We're going to be plotting a horizontal bar chart over here to make it easier for you to see. To have a bidirectional bar chart, you need positive values and negative values. The center is going to be at 0. So here we're going to be making the loss feature as negative by multiplying the loss feature with the -1 value. So here we go, the losses are all negatives and the wins are all positives, right? Now let's run this and see how many losses and wins have occurred for each user. So user 1 has 42 losses and 58 wins, but you can easily see whether they have won more or lost more by comparing the height of the bars for the wins and the losses. So we can easily say that in this scenario, user 1 has won more times than they've lost. The same can be said for user 2, where the wins bar is significantly higher than the losses bar. So this is how you can plot and understand a bidirectional bar chart. So we've taken a look at how we can plot bar charts and the various types of bar charts that are available to us in Python Bokeh. Now let's take a look at area plots. Area plots is a combination of the line and the bar chart when the area below a line is shaded. Using an area chart, we can see how the values of different groups change over a period of time. The area chart has different baselines to show the vertical range of data. Here we've plotted the sabotages fixed versus the minutes at which they were fixed at, right? So these are the minutes, and the sabotages fixed are of two types, 0t and 1t. So the number of minutes that we're considering here is somewhere around 28-ish, right? And 0t, as you can see, has a way higher value. So one really good thing about area plots, especially in this case, is that they have two ranges. And they have another range on the y-axis, which tells us how the number of sabotages fixed is ranging. So 0 sabotages fixed, you can see how the value keeps fluctuating and how the value changes for different minutes. And the same can be said for 1t. Now 1t has a baseline which is over here, which is just above the 0t baseline. This doesn't necessarily mean that this is where 1t starts and this is where it ends. This just means that it ranges from 0 all the way here, and we can compare very easily how 0 sabotage is fixed and 1 sabotage is fixed range or change with respect to each other at the same time. Now the first thing that we're going to be doing to plot our area chart is that we're going to be creating another data frame. This is called df minutes, which is going to be comprising of the minutes column of our data frame and the sabotages fixed column of the same data frame. For df min, we're going to be renaming the columns to 0t and 1t. And the only columns that we're going to be considering out of the 5 different columns that we have are the 0t and the 1t column. We're going to be combining all of these together in a format which can be plotted by using Bokeh, and column data source helps us do this. It helps us convert our various data frame columns into lists. Next, we're going to be using the figure function, and we're going to give our figure a width of 400, a height of 400, and the title of sabotage is fixed versus the minutes at which they were fixed at. To plot a stacked area graph, you're going to be using vArea underscore stack function from the figure module. You're going to be passing in your y parameters, which is y0 and y1, because we have two different y parameters here, and the x parameter, which is df minutes. The color that you're going to be using is gray and light gray. The legend labels are the names that you've already put here, which is 0t and 1t, and the source of your data is going to be this column data source. Now let's run this and see how our area chart looks. So this is our area chart. we've gotten two different sabotages here and two different times at which they occur, which is 0t and 1t. The minutes tells us how many sabotages were fixed at each time, basically how long it took to fix a sabotage, and the minute during the game at which they occurred. Now let's take a look at the layout function of our Bokeh library. The layout function will let us build a grid of plots and widgets. We can have as many rows and columns or grids of plots in one layout. Using the layout function, we can see various graphs at the exact same time. Mainly used for designing dashboards, it lets you build grids of plots. So this is basically what your layout function will help you do. This is going to look very good in a website because it's going to arrange our plots in a way that we can easily see all of them and understand all of them without any loss of data. This is also arranged very neatly, which is exactly what the layout functions allow us to do. So now let's take a look at how the layout function can be implemented in Python Bokeh. Now of the layout functions, there are many different layout options which are available. You have the column function which allows you to display plots vertically. And you have the grid function which lets you display plots in the form of grids. Now, for example, let's say that we want to make a dashboard layout in Bokeh. We are going to be considering three different charts. The first one that we're going to be considering is a lollipop chart, which is done here. The next one that we're going to be considering are two pie charts. So this is how you plot a lollipop chart, and I'll show you what exactly a lollipop chart is in just a minute. The first thing that you need to know is that the first graph that we're going to be plotting is going to be a graph which has the user ID versus the outcome of the games plotted on it. So what we're going to be doing here is that we're going to be creating a single data frame which has all of the user IDs present in it along with the user and the wins that the user has obtained. Now using this, we're going to be plotting it in the form of a plot in decreasing order where we have the top 10 users who have won, which basically means that the users who have won the most number of games out of all the users in consideration. So figure 1 segment will basically help you plot a line which has a width of 2 and a circle will be at the very top of this segment. So lollipop chart is going to be a horizontal line with a circle at the very top. Sorry, the next graph that we're going to be plotting is going to be a murdered and not murdered and missing values pie chart. And the last thing that we're going to be plotting is a donut chart of the teams and the values within them. So these are the three different graphs that we're going to be plotting, and these are just us creating the graphs and plotting them. The main logic is over here. The main logic is that you want to set a layout in Bokeh as to how you want to see the charts. So the layout that we are going to be looking at is that we're going to be having a lollipop chart at the very top and two smaller pie charts at the bottom, right? So we have three figures here. And the first thing that we're going to be doing is that we're going to be giving these figures a line color of none. The axis is not going to be visible and the axis labels are not present for these figures. This is the main function that you're going to be looking at. This is your layout. Using the grid layout function that you've imported here from bokeh.layouts, you're going to be creating a grid. And how does the grid know where the figures are? So you've divided the grid into two. This is evident because you have two main figures here, which are separated by a comma. So this tells the grid that the page is going to be divided into two. The first figure, which is on top, is going to be figure 1, and the figure at the bottom are figure 2 and 3. This means that the bottom half is going to be further split into vertically. Let's run this and see what our layout looks like. So here you have it. Your entire page is divided into two The first one has the figure 1, which is the lollipop chart, and the bottom half of our page has two figures, which are the two donut charts. The bottom half is divided exactly into two, as you can see here. This is because that is the grid layout that we wanted. So this is how you can use the layout function in Python Bokeh. It is extremely easy. All you have to do is create a layout by using the grid function, or you can also use the column function. The column function will plot it in the form of a single column vertically. Using the grid function, you can plot figures vertically as shown here. So when you separate them by commas with respect to each other, they will be plotted vertically, and when you group them together and separate them with commas internally, they will be plotted horizontally. So now we've taken a look at how we can use a layout function. Now let's see how we can make interactive graphs with the help of Bokeh. Over here, we're going to be using Bokeh to design a dashboard which is used to represent the horsepower in cars. We are also going to make our graphs interactive and see how maximum information can be conveyed with the help of a single graph. So here we have multiple different cars, and along with the cars we're also going to be given their horsepowers, a little bit of other information about them, and their images. And over here, as you can see, we have a very simple vertical bar chart. But let's see how we can make it interactive and convey all the information that we have in our single data set on this one bar graph. So the first thing that we're going to be doing is importing all of our important necessary modules. We're obviously going to have the pandas modules, which is going to be imported to work with the data frame that we've given. Apart from this, we're also going to be importing figures, output file, show, save, and column data source from bokeh.plotting. We already know that the figure function is used to plot different types of graphs which are given. Output file is just used to see our file. The show is used to display our graphs, and save will help you save your graph. Now, the column data source is the core of most Bokeh plots. It provides the data to the glyph of your plot. When you pass sequences like Python lists or NumPy arrays to a Bokeh render, Bokeh automatically creates a column data source with this data for you. So this is basically what you're going to be using to pass data onto your Bokeh glyphs. Apart from this, we're also going to be using a hover tool function, and from the transform function, we're going to be importing factor CMap. We're going to be importing a palette color, which is going to be various shades of blue. And we're going to be importing components from the embedded function of Bokeh. Let's just see how we can use all of these and the different things that they do. The first thing that you're going to be doing is reading in your car's data frame and creating a column data source so that you can easily parse this data onto your Bokeh glyphs. So let's run and import all of our various required functionalities and import the data as well. So this is what your data set looks like. We have 8 different values in our data set, which are the names of different cars, their horsepower, their price, and a hyperlink of an image. This is what our data set looks like. We have only 8 columns. So using this data set, we're going to be plotting a horizontal bar graph. Again, we're going to be calling our figure function, and we're going to be giving y-range to our car list. The y-range is basically just going to have the different values which are going to be present on the y-axis. We've given the plot a width of 800 and a height of 600. The title of the plot is Cars with Top Horsepower, and the x-axis label is horsepower. The tools that we're using here is pan, box select, zoom in, zoom out, save, and reset. So these are tools that you're going to be getting on the right side of your plot. Now let's render our glyph or render our graph. The graph that we are going to be using here is the horizontal bar graph. So the y-axis is going to have cars, and the right, or basically the height of the entire bar, is going to depend on the horsepower. The left is going to start from 0, and the height of each bar is going to be 0.4. The color that we're going to be giving is going to be a palette of blue. So each different car will have a different color of blue associated with it, and the color of blue which is associated with it will depend on the car list. Now fill alpha 0.9. The source is your source data that you have over here, which is the column data source of our data frame. And the legend is going to be car, which basically means that your entire plot is going to have the legend of car. Now we're going to be adding the legend. This is us giving the legend its orientation. So the legend is going to be vertically oriented. The location is going to be on the top right, and the font size of the text car of our legend is going to be 10 px or 10 pixels. We're also going to be adding a hover tool. Inside this hover tool tips will basically tell you what you're going to be seeing in the hover tool box. So we're going to be creating this with the help of an HTML format. The first thing that you're going to be seeing is the name of the car. The next column will have the price of the car, the horsepower of the car, and the image. Now the image is in the form of a hyperlink, and this is going to be auto-populated in your hover tool. The width of the image is going to be 800. So we are going to add all of these hover tools to our P image, and we're finally going to be showing you the graph and what it looks like. So this is your Bokeh plot. Here the title of the plot is cars with top horsepower. This is your legend, which is cars. The name of each car is given here along with the color which is associated with it. Here are the different tools that we have. You can save this, you can reset it, you can zoom out, you can zoom in, you can select the boxes, and you can pan your image. So here we're zooming in, here we're zooming out. If we save this, the plot automatically gets downloaded in your system, and if you reset it, the image goes back to exactly what it looked like when it was first opened. Now here you have the names of the different cars on the y-axis, and you have the various horsepowers on the x-axis. Let's take a look at our hover tool. So here you have the name of the car which is on top, you have the price, and you have the horsepower, and as you can see, you have the image which is populated instantly from the hyperlink that was available to us. Now the color palette associated with each car gets darker the more the horsepower of the car increases. So here we have cars with top horsepowers which are arranged in an ascending order from the top and a descending order from the bottom. So this is another way that you can use Bokeh to create extremely interactive and informational graphs. Here in just half a page, and this is us making a huge plot, right? We can also decrease the size of the plot if you want to. But basically in half a page, we've conveyed all the information ranging from the name of the car to its model to the horsepower that it has, its price, and also its image. And this is also a very good way to compare it. So these are just some functionalities which are provided in Bokeh itself. No other data visualization library will let you work so well with graphs and will let you customize your graphs to this extent.
That's all for today's session. Thank you for watching the video. I hope you all found this tutorial informative and helpful. If you have further queries regarding any of the topic covered in the session, feel free to let us know in the comment section below, and our team will be happy to resolve all your queries. Until next time, stay safe and keep coding.